All right, guys, so dividing radicals today. If you remember when we did dividing radicals back with just square roots, like it's one of the first things we did for the semester, right, Tara? Yeah, okay. You guys struggled with this one. You struggled then because you didn't listen to me. So maybe you'll listen now. If you can divide or simplify first, do that, okay? You guys were like keen on, ooh, there's a radical on the bottom. I'm going to rationalize. Like that was like you wanted to do it right from the start. Can it work? Yes. Do they get muddy and ugly and nasty? Yeah, and especially so on these. So if you can divide or simplify your fractions first, do that. Okay? You guys gonna listen to me this time? John, you gonna listen to me this time? I did last time. I took offense to that. Okay. So number one, cubed root 189x to the 7th divided by the cubed root of 7x squared. They're both cubed roots. I can divide them. What's 189 divided by 7? 27. Now, have I done anything with the cubed root or the cubed root yet? No, so that is still there. So if I divide them, I get 27. X to the 7th over x squared is x to the 5th. Okay, so step one, simplify or divide as much as you can. Now, if one's under a radical and one's not, then obviously they don't work together. But they're both under the same radical. I can go ahead and put those together. And now simplify that. Cubed root of 27 is 3. Cubed root of x to the 5th. How many groups of 3 can I take from there? I can take one group of 3, and then there'd be 2 left over. Again, for those of you who need the visual, I have 5 x's. I need 3 in a group, so I can take one group out. That's why there's one x out here. And there'd be 2 that stayed underneath. So number 2, same idea. So 4th root. Now notice here my radicals were split. Here it's one giant radical, means the same thing. So what's 243 divided by 3? And then x to the 3rd over x to the 7th. X to the 4th would be where? On the bottom. Now, I want you guys to recognize kind of what just happened there. Yeah. And, I mean, you can think about, if you think about it in terms of your rules, what John was just saying, 3 minus 7 is negative 4. It's negative, so we'd have to move it to the bottom. The other way we just kind of think about it, I can cancel those 3, cancel 3 out, there's still 4 left. Where are they sitting? They're on the bottom. So they got to stay on the bottom, right? Because normally we're like, oh, look, I can cancel those 3. That would change that to a 4, right? Where is it sitting? On the bottom. It stays on the bottom. Mm-hmm. Mm-hmm. Yes. Yep. Always taking whatever that index is. I want groups of that many. How many groups of that many can I take? Questions where I'm at on this one so far? The biggest mistake I see students make with these is they're like, oh, it's 81 over x to the 4th. Circle it and call it good. They didn't use their toilet paper. Gross. Yeah. But I mean, some people just lose the radical altogether. They just assume it went away. So, but now I have to do this. What's the 4th root of 81? It is 3. 4th root of x to the 4th? It's x. Just kidding. Because if I have 4 x's, how many groups can you get out of there? I can get one group, so it's x to the 1st. Yeah, they're not canceling. All right, number 3. So can I divide 63 divided by 7? That's 9. What happens to my x? Stays there, nothing cancels or anything with it. Y squared, good, because this one's going to cancel out and make that a 2. So y squared. Yes. Yep. All right, so what's the square root of 9? Can I take a group of 2 from the x's? So he stays there. And then square root of y squared? It's just y. Why don't you guys try number 4? All right. Ask me later. Ask me later. All right, so number 4. simplify anything and everything you can first. So 54 divided by 2. X to the 5th and x squared is going to give you x cubed, and then y squared. So everything stayed on top, everything's still under the radical. I have not used that radical yet. All I did was divide. Square root of 27, nice and pretty? No. So we'll do our factor tree. That's not pretty, we have to factor tree. So I want groups of 2. So I got a pair of 3s. The single guy stays back underneath here. Square root of x cubed. How many groups of 2 can I take? One group, how many would be left over? Square root of y squared. Just one y, none left over. So 3xy, radical 3x. How are we feeling so far? All right, 162x over 6x cubed, all underneath. Yeah, it's 162 divided by 6. Does that divide nice? 27? So 27. And then x over x cubed is going to become, where's the x squared going to be? On the bottom. And again, you'd be like, all right, I want to cancel that x, and that one's going to turn to a 2, right? Just like what we were doing in the last chapter. So it stays on the bottom. Square root of 27. We just did the last problem. It becomes 3 radical 3. Square root of x squared. I have a radical on the top still. Is that okay? Where am I not allowed to have a radical? Bottom. Ooh, I got a cubed root going over there. 108 divided by 2? What about the y? Stays there. What about the x to the 6? Where is it? It's on the bottom. All right, so there was step 1 of just simplifying. I have not used the cubed root, so it's still there. Now I'm going to attempt to use that cubed root. Cubed root of 54? Is it pretty? Okay, if it's not pretty, factor tree. 9 and 6, 3 and 3, 3 and 2. How many do I need in a group?
3.
Basic math's hard. So I got a group of 3s I can take out, and then I have that 2 stays underneath. Don't forget your little index of a 3 or it's wrong. What about the y? Stays. I can't take 3 y's because there's only one, so he has to stay. X squared. Yeah, think about 6 x's. And I need groups of 3. There's one group of 3, 2 groups of 3. So what's x squared? Yeah. Yep, it's the leftovers. I don't have 3 y's to take out, so he has to stay in. He's watching Netflix. That's right. Okay. Now we're going to look at ones that don't always end up so nice. You guys ready over there? All right, so rationalizing the denominator. The questions come up, how do people struggle with this? This, if you're going to fall apart, it's going to be right here. If you're good with this, then you're the master, and I'm very happy. Okay, but this is usually where it happens. A simplified answer does not have a radical in the denominator. We know that. To eliminate the radical, blank the top and bottom of the fraction by the same radical. Multiply. Right, we always multiply top and bottom by whatever the radical is. We always do top and bottom, right? Same thing. Now, why this is harder is because we don't always multiply top and bottom by whatever the radical is on the bottom. Not like we did with square roots. The radical used to rationalize should have enough bases to make a blank so that the power and the root cancel each other. To make an exponent so that the power and the root cancel. And I'll explain what that is here just in a minute. All right, now this is where people fall apart, is that last part right there. And it's because basic math is hard. That's why. All right, so we're going to start nice and slow. Number 7, rationalize the denominator and simplify. Now that's a square root. So think back, how did you rationalize when that was a square root? You multiply top and bottom by square root of 5. Right? So you're like, yeah, no big deal. That's 3 radical 5 over 5. Now let's talk about why you did that. There's rhyme and reason why you did that versus how we're going to attack the next ones. What's the index on this square root? It's a 2. So I wanted to make this so that my 5 had an exponent that matched that. This was 5 to the first, and this is 5 to the first, which makes 5 to the second. What's the square root of 5 squared? It's just 5. Because this and this like cancel each other out. Just the same way when you guys did the square root of x squared, you told me that's just x. So that's what I want. I want my index number and my exponent to be the same so that they, in essence, cancel each other out. Okay? So if I look at the next one, this is 2 to the first. So when I multiply top and bottom by the cubed root of something, I can't just multiply it by the cubed root of 2, because that's not going to give me the exponent I need. How many more 2's do I need? I need 2 more. I have 1. I need 2 more. Because now I have, just looking at the bottom, that would give me the cubed root of 2 cubed, which is, what's the cubed root of 2 cubed? It's 2. So that puts a 2 on the bottom. And on the top, what's 2 squared? Times 3. 12. So I have the cubed root of 12. Right? And again, hold on. We're going to go through a lot today. I know this gets confusing. So whatever your index is, that is how many you want of each piece underneath that radical to get rid of them. So I had just 2 to the first. So I need 3 of them. I needed 2 more. So then that gives me 3. So that they just cancel each other out and it's just 2. Whatever that index is, that's how many I want of each piece. Whatever you multiply the bottom, you have to multiply the top. What's 2 squared? Times 3 is the 12. Yep. And that's where I got 2 cubed, which the cubed root of 2 cubed is just 2. Oh, yeah. Absolutely. Yep, absolutely. 2 squared is 2 times 2 is 4 times 3 gives me the 12. Yep. And we're going to do a lot. I know, like this is the trickiest part. So on number 9, I have a 5th root of x squared. How many more x's do I need? I need 3 more. Basic math's hard. I have 2. 3 more will give me 5. Right? So this now has become the 5th root of x to the 5th? Okay. But if I multiply the bottom, I also have to multiply the top. I got to be fair. Yep. So on the top, 6 times the 5th root of x cubed is 6 times the 5th root of x cubed. And on the bottom now just becomes x. And again, this is, I know, don't go and get frustrated. It'll take time. I'm looking at whatever this index is. That's how many I want of whatever's underneath it. The bottom, the fifth root of x squared times the fifth root of x to the third becomes the fifth root of x to the fifth. Right, your properties say you add your exponents, put them together. What's the fifth root of x to the fifth? I didn't subtract. What's the fifth root of x to the fifth? It's just x. Because this means I have 5 x's. I'm on a group of 5. I have one group. You overthink it sometimes. That's all right. We'll do more. The more you see, the better it gets. All right. Now, on number 10, what do you notice right away? It's one giant one. What do we always do with those? We split them. Yeah, let's go ahead and split that. So that's, yes. Whatever that radical is, I can't really change it. It has to stay with that index. Now, because it wasn't complicated enough, I'm going to switch you up a little bit. Sorry. Now, right now, some of you may look at that and be like, oh, okay, there's 1 4, so you want 2 more 4s, right? I don't want 2 more 4s. Right now, don't write this down. Right now, this is 4 to the first. I need it to be a 3. I need 3 of whatever's under there. So hold on. So a lot of times students see this and like, well, I need 4 squared. Right? Because 4 squared, that would be there's 1 4 and 2 more, that would give me the 3. Which will work. It's not simplified though. Yes. What is 4? That's 2 times 2. Hold on. So this, let me rewrite. So the top hasn't changed. I'm not messing with the top. The bottom's my issue. I'm going to rewrite this as 2 squared. Yeah, 2 squared is 4. Did I change the value of anything? No. You want to try to rewrite your bases as simplest form. Yeah. No. Like look at number 11. How would you rewrite 9? 3 squared. Number 12, how would you rewrite 25? 5 squared. Okay, you want to try to take them down to the smallest base you can. Reason being, no, I won't give you something insane. There'll be numbers that you recognize. Now, so right now, I need 3 on the bottom. I only have 2, so what do I need? I need 1 more 2. I need you guys to understand what our point and process is here. I need whatever this index is, I need that many of whatever's inside my radical, whether it be a variable, a number, whatever it is. So your numbers, rewrite them in the smallest base possible. Right, 4 is 2 squared. Because now look, I have 2 of them. If I have 1 more, what do I have now on the bottom? This bottom now gives me the cubed root of 2 cubed. I have created a bottom where I now have something perfect. I needed 3. I had 2, so I needed 1 more to give me 3 of them. Some of you are still looking at me like I'm crazy. So, yes, they're the same. So on the top, we have the cubed root of, what's 5 times 2? The bottom gives me the cubed root of 2 cubed, which is just 2. And again, the more we do these, the more it starts to click. I get it. It's hard. It is hard.
I didn't realize you put those 2 together on the bottom.
Yes, that's why I had that big giant thing underneath there. I was putting those together. Let's look at the next one. So 3 over the cubed root of 9. 9 you would rewrite as 3 squared. So I have 3 over cubed root of 3 squared. That's a weird looking 3. All right, 3 over cubed root 3 squared, right? 9 is 3 squared. I did not change the value of anything. I just rewrote it. How many 3's do I need to make it perfect on the bottom? I need one more. Because again, my index is 3. I only have 2. So I need one more. Right? 3 squared and 3 to the first gives me 3 to the third. If I multiply the bottom, I also have to multiply the top. So on the top, I have 3 times the cubed root of 3. Maybe I'll go kind of an extra step here. This gives me the cubed root of 3 cubed, and the cubed root of 3 cubed is just 3. So I have, hold on, 3 times the cubed root of 3 over 3. It's a lot of 3's. Yes, and your 3's on the outside then? Yep, it's just the cubed root of 3. I know it's a lot. Rationalizing is tough. Now, does that mean we jump into rationalizing right from the start? No, we still simplify if we can. In these problems, we're just really stressing the rationalizing. But no, simplify first, everything you can. Then if there's still a radical, then you rationalize. Yes. Mm-hmm. You can do the same thing with the 3's. Mm-hmm. Am I still losing you on how I'm going from here to here? 3 cubed means I have 3 3's. That was weird. How many groups of 3? 1. So that's 3 to the first, or just 3. I don't think we're ready yet. All right, number 12. First thing, what should we do with that? We should split that. Yeah, it's. Well, could you simplify?
Yeah.
You can. Nothing divides, no x's, no y's, no z's, nothing cancels. So. Well, yeah, but we're splitting first. So cubed root of x squared on top. The bottom's going to have the cubed root. What would you write for 25? 5 squared. And then y squared and z. Oh my. Okay, so this one's got extra steps to it. Because look at all the stuff on the bottom. So just kind of one piece at a time here, right? We can't leave the radical on the bottom. So we're going to multiply top and bottom by the cubed root one piece at a time. So how many more 5's do I need?
1.
Right? I need 3 altogether because that's my index. I have 2 of them. I need 1 more. How about the y's?
1.
I need 1 more of those. I already have 2. 1 more would give me the 3 I need. And my z's, I need 2 more of those. So that way, it's giving me 3 of everything on the bottom. So when I multiply, I'll just kind of go one step at a time here for you. On the top, we get the cubed root of what? On the top, we have a 5, an x squared, a y, z squared. On the bottom, yeah, I'll go one step at a time for those who need to see it. 5 squared and 5 is going to give you 5 cubed. Y squared and y gives you y cubed. Z and z squared, z cubed. And what's the cubed root of all of those cubed things? It's just going to be 5yz. So no more radical on the bottom. The top, can I take a group of 3 from any of those? No. So it's just going to stay 5x squared y z squared. Now, if you did not rewrite 25 as 5 squared, just want you to think through this. Don't write it down, but just kind of think in your mind. If I left that as a 25, that means you would have to multiply top and bottom by 25 squared in order to make 3 25s. What's 25 squared? 625, which then you would multiply by the top, and then you'd have to simplify that. So do you see why we rewrite 25 as 5 squared? Your numbers stay a lot smaller, and then there's really not any simplification going on. It makes it a lot easier. How we doing? Not bad. Okay, that's what I like to do. Oh, yeah, yeah. Yeah. Uh-huh.
Don't simplify the top.
You do if you can. But in this case, 5 doesn't break down into a factor tree or anything. I need groups of 3. I only have 2 x's, 1 y, and 2 z. So I can't take a group of 3 from anything. But if you could, then yes, you absolutely would. Let's look at 13. What do you do first? Should I start rationalizing? No, no, no. Simplify. Thank you, Marty. Simplify. Can I do 54 divided by 2? Yeah, it's 27. X to the 5th over x to the 6th. It's going to be an x on the bottom. Again, I have not used my cubed root, so it's still there. Don't assume that it's gone when I start dividing. And then y cubed over y. Y squared on top. So yeah, so there's step 1. Simplify it. Because look how much nicer that looks when I simplified it. It looks a lot less ugly and fewer parts to worry about. All right. Well, we know that I cannot leave a radical on the bottom. I'm going to have to rationalize. So I multiply top and bottom by the cubed root of x squared. Because I had 1x, I need there to be 3, because that's what the index is. So I needed 2 more. Yeah. Oh, yeah, I didn't do that, did I? Yeah, you probably should. Yeah, no, thank you. My brain was, I was doing what you guys do. I was so excited to rationalize, I forgot to look at the top. Thank you. What's cubed root of 27? Can I take a group of 3s from the y's? No, okay. Thank you, Sam. Yeah, so we could have simplified on the top. Cubed root of 27 is 3. So that doesn't change what I multiply by, though, right? I still need cubed root of x squared. That way it rationalizes. Oh, absolutely. Yep. If you guys didn't hear Izzy's question, she said, could I simplify later if I didn't realize it then? Yes. Honestly, what I would do, even if I think I'm simplifying all the way, my final answer, I'm going to look at again and be like, can I take any groups of 3 out of there? Like, just in case I missed it earlier. Okay? All right, so on top, we have a 3. I have a cubed root of, thank you for saying that in alphabetical order. Makes my heart happy. And then what's the cubed root of x times the cubed root of x squared? It's going to be x because it's going to become the cubed root of x cubed, which is just x. Before you circle your final answer, can I take a group of 3 from the x's or y's here? And there's no radical there. Anything cancel? No. Always double check. Because just like me, I do this all the time. I just totally forgot to do that until Sam said something. It happens. Okay? So just always look at your final answer, make sure everything's as simplified as it can be. One's under a radical, one's not. So I can't cancel those. Do you want to try 14 on your own? Let me give you like a minute. Do as much as you can, and then I'll go over it with you. All right. Let's go through it and see how we did. Or if you're lost, that's okay. We'll go through it together. So step 1, simplify if you can. 5 divided by 2? That doesn't divide. So we're going to leave that. All right, so we have the 4th root of 5 over the 4th root of 2. So I can't actually divide, so just leave them there. X cubed over x, what's that become? Where does it go? Top. X squared on the top. Right, because this x cancels, going to turn that one into a 2. Y squared over y cubed, y at the bottom. Right, cancel those 2 out, and then that's just going to be 1 left. So I have 5x squared over 2y. Do we understand what I did, though? You got that part right? All right. Hannah, you're like on this. Or I called you Hannah. Tara. Tara, you're on this today. Yeah. Sorry, the blonde hair went right through to her. What? I don't know why you think that. They're the same, put them together. They're both underneath the radical. They're not attached to the plus or minus. They're fair game. Now's not the time to ask. I'm in the middle of going over a problem, John. Not the time. All right. From there, I simplified everything I can. Still a radical on the bottom. Can I rewrite 2 with a smaller base? No, it's just a 2. Okay, so I need to multiply top and bottom by the 4th root of what? How many more 2's do I need? I need 3 more. What is 2 cubed? What's 2 cubed? That's 8. You guys okay if I write an 8 up there so it makes more sense when I go to multiply? What? Do I want 4? I want 4 altogether. Here's 1. I don't want the number 4. I want 2 to the 4th. Two cubed is 8. How many more y's do I need? I need 3 more, right? I need 4 altogether. Here's 1. I need 3 more to make 4. So on the top, I have the 4th root. 2 cubed is 8 times 5 is 40. Then I have an x squared and a y cubed. On the bottom, what does that become? That's just 2y. The 40 is under a radical, the 2 is not. So no, I can't. Yeah. Okay, so the question was, does 40 simplify? Okay, if I would do a factor tree on the 40, that's 4 and 10, 2 and 5, 2 and 2. I need a group of 4. I don't have a group of 4. All right. The 2y from the bottom came from, if I would multiply the bottoms together, 2 to the 1st and 2 cubed gives me 2 to the 4th. Y and y cubed is y to the 4th. And the 4th root of 2 to the 4th is 2. 4th root of y to the 4th is y. We're always creating something so that it's just whatever those numbers are.